Absolute value is what we're going to cover in this screencast. This is the last section in the chapter. And in this section, we're going to learn how to solve an absolute value equation and an absolute value inequality. So first of all, let's go over the definition of absolute value. So the absolute value, remember, by definition, if the absolute value of x is equal to a, then x can be equal to negative a, or it's equal to positive a. You could think of that as the opposite of a, or it's equal to a itself. Let's look at a specific example. So if it says the absolute value of x is equal to 6, then what could x be? Well, x could be 6, or x could be negative 6. What's going on graphically? Let's look at that real quick. So graphically, if we graph the absolute value of x, that graph looks like this. Now, we want to know, when is the absolute value of x equal to 6? So here's the equation for y equals 6. So we want to know, when is the equation equal to 6? Well, that's happening here, the absolute value equation, when x is negative 6, and it happens here when x is positive 6. Okay? So that's what's happening graphically. That's sort of an overview of the equation part of it. Well, let's look at the inequality part. What if I asked you, when is the absolute value of x less than 6? Well, right here and right here is when the absolute value is equal to 6. So when is that blue graph under the red graph? That means less. So when is the blue absolute value, that v, under the red line? Well, that happens on this interval from when x is negative 6 until x is 6. All right, try this one. When is the absolute value of x greater than or equal to 6? So look at the graph and describe the intervals when the blue line is above the red line. It goes from negative infinity to negative 6, and then again from 6 to infinity. Now, why do I have a bracket here? I have a bracket because we are including negative 6, and we are including 6. That's because of this line under the inequality. Okay, now let's go through a series of examples. We're going to do a couple equations, we're going to do a couple of inequalities, and then we'll be done. All right, so our first equation, the absolute value of 2x minus 3 is equal to 6. Remember, like I said before, that means what's underneath that or inside those absolute value bars, either equal to 6 or it's equal to negative 6. That's the definition of absolute value. So I have two equations to solve. I'll solve the left side first. So then 2x is equal to 9 when I add 3 to both sides, and then I'll divide by 2. X is equal to 9 halves. That's just one of my answers. I have another one that I'm going to get when I solve this equation. So 2x equals negative 3, and that means x equals negative 3 halves. So those are the two solutions to the absolute value equation. All right, let's look at another example. The absolute value of 3x plus 1 minus 4 equals 6. I can't separate this until I have an absolute value all by itself. So what I have to do in the first step is add 4 to both sides. Now I can separate it just like I did in that previous screen. So that means 3x plus 1 is equal to 10, or 3x plus 1 is equal to negative 10. And when I solve those two separately, I get two answers, 3 and negative 11 thirds. All right, good job. Equations are done. Let's switch our focus to inequalities. So notice I have the absolute value of 2x plus 3 is less than or equal to 9. When I separate these, like I did with the equations, it's very similar, but what's different is I have to switch the direction of the sign. So I have what's inside is less than or equal to 9, or what's inside is greater than or equal to -9. Two things changed here, guys. This is not less than, it's greater than, and this isn't positive, it's negative. And then we're going to solve each of those inequalities separately. We're going to solve the one on the left. 2x is less than or equal to 6, which means x is less than or equal to 3. And then we're going to solve the right-hand side. 2x is greater than or equal to -12, which means x is greater than or equal to -6. Now, these solutions are intervals. You're going to be asked in your homework to graph them and write them in interval notation. This is what the graph looks like. X is less than 3. At the same time, x is greater than -6. So it's all the numbers that are in between here. And notice I used a bracket on the endpoints. That's because of the line underneath here, which means they're included. Now, what this looks like in interval notation is it goes from -6 to +3, brackets on both ends. All right, one last example for this chapter and for this section. So the absolute value of 5 minus 2x is greater than 10. I'm going to separate those. 5 minus 2x is greater than 10. 5 minus 2x is less than -10. Look, guys, switch two things. This is greater than, now it's less than. This was positive, now it's negative. Now on the left side, after I subtract 5 from both sides, I get -2x is greater than 5. Do you remember when you divide by a -2, you have to switch the direction of the sign? So that means x is less than -5/2. Same thing happens on the right. So I have -2x is less than -15. And when I divide by a -2, I have to switch the direction of the sign. So x is greater than 15/2. When I go to graph this, notice parentheses here, guys, right? It's parentheses because there's no line under here. It's not equal to. And we have everything up to -5/2, not including -5/2, and everything from 15/2 to infinity, not including 15/2. This is what that looks like in interval notation. All right, good luck. Let me know if you have any questions.